Let's take a look at how most mixture problems are set up. Typically there's going to be containers such as X that has a certain amount of material at a certain percent. Then there's another container, let's call it Y, that has a certain amount of material at another percent value. And what typically we're going to do is we're going to take this and put it into a third container and mix the Y as well into the third container to get a new solution. And what we need to typically find out is in the final container here, what is the total amount of material? And I think this is pretty straightforward. 10 liters plus 20 liters is going to give us 30 liters of material. And then the harder part is to figure out what percentage of salt are we going to have. Now this one has 15% salt, this one has 15% salt. So our final solution is very simple. In this case, we're going to have 15% concentration of salt. The 15% here means that 15% of the solution is salt and the other 85% water. Most of these mixture problems are not going to be like this, where the percentage is the same. Now, this is more typical of the kind of problem that you have to solve. First of all, we can see this still has 10 liters, but we've changed the amount of the concentration to be 10%. And our final amount here has to be at 17%. Our Y container this time has a solution of 20%, and we have an unknown quantity here. When we pour this into our container here, we have to pour enough of this concentration into here so that it's going to increase to 17%, the solution that's in Z. Now this is a fixed amount, 10 liters at 10%, but in this case we can add as many liters as we want of 20% to bring it up to 17%, and we have to figure out how many liters that is to give us a 17% solution in the other container. Now, one of the things we know before we start our detailed analysis, and to help us come up with the equation we're going to need, let's take a look at what's going to happen when we add X here and Y together and put them into Z. Well, there's 10 liters here, so the total amount that you're going to have is 10 liters, but then we're going to add X liters here, and that's what we're going to have as the total amount of liters that we're going to have in Z when we're done. We also know that the solution in X is 10%, which means 0.1 times 10 liters. And that's going to give us a total of 1 liter of salt in here. Now, in the case of this is going to be 0.2x. Now, if X happens to be 5 liters, that's going to give us 1 liter of salt. If we have 10, that's going to give us 10 times 0.2 is 2 liters of salt. And over here, this is going to be 0.17 because we want 17% solution of 10 plus X. So our equation is going to be 0.1 times 10 liters plus 0.2X is equal to 0.17 times 10 plus X. And that will be the formula that we're going to use to solve this problem. For this problem, we're going to let X equal the amount of material that's in the Y container here. And the amount of material in container Z when we're finished is going to be this amount, which we pour in, plus this amount we pour in, which is going to be X plus 10, or 10 plus X, liters put into the Z container. What this means is 0.1, or 10% of 10 liters is going to give us 1 liter. 0.2x times the number of liters is going to give us 0.2x liters. And over here we have 0.17 because we have 17% concentration here of X plus 10. So that's going to give us 0.17x plus 1.7. And when we solve it, we get X is equal to 23.3 liters. So that means we had 10 liters here, and when we substitute that in, that is going to give us 23.3 repeated liters here. And when we're finished, if this works out, this is going to give us a total of 33.3 repeated liters of total substance in the Z. Let's check to make sure that works properly by checking our left side of our equation by the right side and making sure that they are equal. If we take a look at the left side of our equation, we have 0.1 times 10 plus 0.2x. If we multiply these out, we get 1. We get 0.2 times 23.3 repeated, which ends up being 5.6 repeated. On the right-hand side of our equation, we have 0.17 times x plus 10, which is 0.17 times 23.3 repeated plus 10, which is 0.17 times 33.3 repeated, which gives us again 5.6 repeated. Since the left-hand side equals the right-hand side, the solution in container Y that must be added to Z is exactly 23.3 repeated liters. Let's take a look at question 1 here. Two different mixtures of gasohol are available, one with 5% alcohol and the other containing 12% of alcohol. How many liters of the 12% mixture must be added to the 250 liters of the 5% mixture to produce a mixture containing 9% alcohol? Now this problem is practically identical to the one that we just did. We have 5% of 250 liters. We have 12%, and we don't know how many liters, and we want finally 9% total concentration of the final solution. Now again, what we're doing is we're pouring this into here, so that's going to be our 250. We're pouring this into here, so that's our X. So again, we're going to come up with a formula such as 0.05 times 250, which is 12.5 liters. Then we have 0.12x is equal to 0.09 times x plus 250. When we do the solution, we find that x is equal to 333.3 repeated liters. So we're going to need 333.3 repeated liters here to do that, which means that our answer that we're going to have for our total amount in our final solution is going to be 583.3 repeated liters here. Let's make sure that this works by doing our checking. If we look at our left side and put 0.05 times 250 plus 0.12x, we end up with a number 52.4 and 9 repeated. If we look at our right side, we do the same sort of substitution here. We end up again with 52.4 and the 9 is repeated, which means this is definitely the correct answer for our problem. Let's take a look at question 2. It says how many tons of pure chromium must be added to 2.5 metric tons of stainless steel that already contains chromium at 11%. And what we want to do is raise the percent of chromium to 18% by adding pure chromium. Now, as it said in the problem, there is 11% of chromium in the 2.5 tons that we have here. We have to add X tons of pure chromium, meaning that's at 100%, to raise the percentage of the chromium to 18%. So there is our 2.5 tons at 11%. There's our X tons at 100%, and we want 18%, and that's going to, as we saw before, when we put these two together, that's going to be 2.5 plus X tons to have it at 18%. Now what this means is we got 0.11 times 2.5 plus 1 times X is 0.18 times 2.5 plus X. When we substitute all this in, we get this value here of X is 0.213 tons. Now if we check the left side versus the right side and we substitute this in, we get 0.488 for the left side when we substitute in, and we get 0.488 for the right side, which means that this is the correct answer for the number of tons that we have to add of pure chromium to make it 18%.